Alright, so we got this question. Use the fact that root 2 is irrational to show that the statement right here is irrational for any positive integer m. So m is a positive integer. Alright, so let's get into it. So we know that root 2 is irrational, and we prove this usually by contradiction. So we'll say let 2m plus 1 square root be rational, and we will prove this by contradiction. Contradiction is just like it says this number is, you have to prove that it is irrational. We'll say, okay, it's rational. So when it's rational, then 2 to the power 2m plus 1 square root must be equal to p over q, where pq is the lowest form of a rational number. And the lowest form of rational number, they can't have like p and q can't have like common factors, because the lowest form of rational number can't have any common factors, where p and q can't have a common factor. Okay, so when we prove this by contradiction method, then if we develop that p and q have a common factor, if we develop that p and q are like even integers, for example, both of them, then they do have a common factors, then there'll be a contradiction. That will mean it's not a rational number, so it is a irrational number. Okay, so let's just break this thing first. Okay, so we can break the stuff in the root by saying 2 to the power 2m dot 2 to the power 1. So that's like property of exponents. Anything that's, for example, 2a plus b is just 2a dot 2b. Okay, so the next step, we can just separate the dot. For example, 2 to the power 2m square root dot 2 square root p over q. So we got root square root 2 out of that statement. Let me just get rid of this. Alright, so how we can break this statement right here? Let's try to do that. So we can write this statement as 2 to the power m square root, because like when it's like this, so this is like dot, right? So we can write this property of exponents, we can write this as 2m, and same thing. Alright, for example, if 2 is 2.3, and if you do 2 to the power 2, 3, then it's like 4 to the power 3, which is 64. And if you do 2 to the power 3 outside 2, you'll get 8 square, which is 64. So it's just the same thing. Alright, so this will just become 2 to the power m dot square root of 2 p over q, where m is an integer, p is an integer, q is an integer. Now we know that we can see that 2 to to the power of any integer is an even number. To the power any, like 2, 3, 4, and so on. It'll be 2, 4, 8, 4, 16, 32, and so on. They're all even. So 2 to the power m is even. Yeah. So root 2 is equal to p over 2 to the power m multiplied by q. All right. So if 2 to the power m is even and q is some integer, then 2m multiplied by q is even number. Yeah, so we already proved that like the underneath the denominator is an even number. So we can let, if p is an integer, sorry, let's just do this. To make it more simpler and like simpler words, we'll let p is equal to a, where a is some integer. A is an integer. Because if p is an integer, then a is an integer as well. And 2 to the power q, where this is even, this is integer, so this is an even integer b. B is an even integer. So root 2 goes to a over b, still the form of rational number, where we've already proven that the denominator is an even number. Yeah, let's just do it on the next page. Where we already proved that the denominator is an even integer. So we have already proven that the denominator is an even integer, but we don't know what it is. It can be even or odd. If it's odd, then it doesn't reach a contradiction, so therefore it is a rational number. If we prove that the numerator a is even, then a and b are both even and they have a common factor, which is 2, so therefore it is an irrational number because we reached a contradiction. So let's see. So writing it further, b square 2b square is equal to a square. So a square is even. Because 2 multiplied by any integer, doesn't matter if it's odd or even, any integer is always even. So if a square is even, then a is even. well, there's another proof. If n squared is even, then n is even. If n is even, then n squared is even. Let's just say we already know that. Like that's another proof. Is even. Okay. So now we have proven that. So therefore, A and B are both even. So they have a common factor. And we have reached a contradiction. So therefore, 2 to the power 2m plus 1 square root is an irrational number. So we've proven it. So we reached this right here. P and Q can't have a common factor, but they do have a common factor, which is 2. So we reached a conclusion, contradiction, and then therefore it is a rational number. There are many ways to solve this question, but this was my way. If you like it, then you like it. If you don't, peace out. Have a nice day. Thanks.